Hey guys, welcome to the last room on the OWASP Top 10 2025. We'll be focused on insecure data handling. In this room, we'll be exploring three of the OWASP Top 10 vulnerabilities that are related to application, behavior, and in-user input. We will get the high-level overview of each issue, learn why it matters, and then put that knowledge into practice through hands-on exploitation exercise. So before we start, let's just start our machines. Okay. While they load, we're going to be covering three vulnerabilities which is like our cryptographic failure, our injection, our software, and data integrity. So we can just start by saying we are ready to learn those. Starting with cryptographic failure, we did cover it in the last in the second room, and now we're just going through it again. Cryptographic failure occurs when sensitive data isn't protected as it should be, either due to weak encryption, poor implementation, or insecure handling. These issues are still extremely common, especially when applications use outdated algorithms, store secret improperly, or attempt to implement custom cryptographic instead of relying on trusted libraries. And in this section, we'll be reviewing common causes of cryptographic failure and best practices mitigation techniques. So let's start with our practical. Our practical says that the practical for this task is located on this. So let's just copy the link. Yes. This web app demonstrates a node sharing service that uses a weak shared derivative key to protect the nodes. Follow the steps on the web application to unlock all nodes and retrieve the flag. And then if you want to explore more about cryptographic failure, you can check out that room. The question is, decrypt the encrypted nodes. One of them will contain a flag value. What is it? So let's go back. Okay, we're on our Firefox. Let's just paste the link and go. We here. It says first we should follow the steps that are given on this page, right? Crypto Lab weak XOR cipher. It talks about the home ground encryption with a short key is easily broken. Then all three encrypted nodes below use the same weak XOR cipher with 4-character key. The key is short. You can brute force it. Enter the correct key once to decrypt all those nodes. Okay. And then we learn here where it talks about encrypted nodes. All three of them are encrypted, and you can see here's the hashes using base 64, encrypted with base 64. But I doubt it's going to just be easy. Said we should use any of those hash, they contain the key. And then when we come here, it says enter the 4-character key to decrypt all nodes at once. The key contains both letters and numbers. Okay, already we see that they are letters. Therefore, maybe the last one could be a number. So we're going to try that. And then here we are told why is XOR cipher weak. It talks about short keys can be brute force quickly, repeating key pattern makes frequency analysis possible, no authentication, you can verify if decryption succeed without context, home ground crypto lacks the security guidance, and so on. Some of the information you can read on your own. So the first thing in my mind, I'm thinking, okay, let's try it with the cyber chef. I know that we can brute force it. We can brute force something with burp suit. So we're going to try both sides. Let's first try on this one. It says meeting reminder. So let's try this. Let's just copy the hash. Copy. Come to our yes input. And then let's look for XOR. And just move it here. The key is something we did say. I'm just going to change it to hexy to UTF-8. The key is key. They did tell us that it's something to do either with it contains characters and numbers. Already from there we see that already these these are characters, therefore the fourth character could be numbers. So let's start by 0. Also let's use base 64. Sorry, I forgot, they did say that it also is encrypted with base 64. Okay, there we go. 0. Let me just move it upwards. Okay, 0 doesn't give us on the first hash, it just give us this unreadable text. We have 3 p.m. the only part that I can read, which means 0 is not it. Let's try with 1. Okay, with 1 we are able to read it. Meeting scheduled for tomorrow at 3 p.m. conference room B. So 1 works for the first hash. Okay, let's try 2. 2 is the same thing as 0, we were unable to read it, and then 3. So now already we can tell that 1 kind of does work. Okay, let's try with that other hash. They said one of them contain the flag. It's here. Okay, let's try the password reset. Let's copy this. And then do the same thing over and over until we get the flag. 0 doesn't work. Let's try 1. 1 does work because it speaks about password reset, link, HTTPS, internal reset password. Okay, I think let's just use 2. 2 doesn't also make sense. It's like random. So we're kind of seeing a pattern that 1 is actually the last digit. But now let's find out what is the flag. We tested out the second hash, which has to do with password research. Now let's do the last hash, which is confidential. Copy this. Hopefully contains the flag that we're looking for. And it does, because look, I just put it to key 1. It does, because now we see that secret, here's the flag, says we crypto flag, do not share this with unauthorized personnel. So let's just copy the flag and then go answer, and then after that let's try to also apply nice. Let's just look at what is the hint that they would have given us. The hint is that the first 3 characters of the key are given to you on the web application. Will you see that? Make a guess as to what the 4th character can be, digit to unlock all the encrypted nodes. We do that. Oh, now we need to go back here and then try a key. Like, let's enter all of them. Key 1 to key 1 to decrypt all the nodes. Okay, and then it tells us that key found, you have successfully cracked the encryption. All nodes are now decrypted, including the flag in node 3. Nice. So here's the decryption. You see here the nodes is decrypted, and we did use that flag. Then the others, like the information that we were just seeing when we used Cyberchef. Okay, now let's just put this down and let's try it with websuite. Okay, we are now on our websuite. Let's move on. Let's start it. Okay, just close this notification. We come to our proxy. I don't want the intercept to be on, and let me just ensure that I'll be able to open browse. I think this stage now you understand it. If you don't, do let me know. Okay, now we can open browse. Oh, I just want to copy the let it load. I just want to copy the link of the URL, copy link, and paste it here. And here I just want to perform a get request. So let me just say 0. It doesn't matter what you enter here. Okay, it didn't work. Okay, and then let's come back to our websuite and come to HTTP history, place the post request, send it to intruder, come to intruder. The first part, like I want to use the snapper attack, and here, this is the part that I want, and then I can just highlight there and say I want to add, and then I can come here, payload type, we need, okay, just close this part, it's fine. Here we say payload type, I want to brute force, we pick on brute force, and here character set, I want to try, okay, this one is characters and numbers, so let's do that. And yeah, everything is set. I'm not going to change anything, so I can just start it. This is just the output, and then I can just close it, and then we can see here's the response that we're receiving. It's trying out all different letters, and then later on numbers. So while it's busy doing this, let's just look, because it's going to try out all different styles and everything. Let's proceed with the others, and we'll come back later to just see how far did it go. But we can see there is the one. You just look into here, like for example, let's try this one to see this is the request. Let's look at the response. Did it work? It did try it. No, this one is not going to work because it tried it with letters and stuff. So maybe let's wait a while it try out all possible. So let's proceed. But you can try it. You can try it here. You can start the brute forcing on websuite as well. So let's proceed with the second one on injection. Injection is one of the most persistent and dangerous vulnerable in modern application. Injection happens when an application takes user input and pass it directly into an interpreter, such as our database, our command shell, or our template engine, without proper handling. This allows an attacker to manipulate how the application behaves. Although injection vulnerability have been around for years, they remain highly relevant in 2025 and continue to appear on the OWASP top 10. And yeah, we review common injection type and prevention strategies. We given them there, and we're going to be carrying out a server-side template injection attack. So let's start here. The practical says today's practical will showcase command injection. This example illustrates server-side template injection. You abuse an application's ability to render dynamic context to retrieve a flag stored on the machine hosting the application. And we can just copy that URL, and let's open another tab. Control V, and then when we come here, we just given this information, and then server side. Let me just ensure that server side template injection playground. This lab intentionally render raw user input inside a Ginger 2 template using render. So I have never really done the SSTI injection. No, so I went to actually search it out. So I was like, ginger, 2 SSTI payloads. That's exactly where I went, and I read more about it. Like I read more about it, like what to do and how to test it out. Then I came here on the on security, the article. So let's just come back because here's the nodes. Terminal can access Python object when node. Sandbox, look for built-in like config, request, cycler, joiner, and libsum, and then try this payload such as this. So let's just try what they're giving us. So you see what output what does it give? Like if we try what they're giving, render payload. Scroll down. Okay, yeah, it's fine. You just see 7 times 7, which is 29. And if we do, let's just copy this as well to see what does it give if we use this. Before trying out with the examples that I given, I forgot to add another. So I'm just gonna use and then Ctrl V and then enter. Okay, it gives us like this output, rendered output, whereby some of them are false, some of them are true. This is not leading us to the flag, like the request that we did. It talks about why this vulnerable, why is this is vulnerable. User controlled string are evaluated as template. Attacker can reach config, call Python built-ins, or leverage object to access host resources. So from this article that I was reading, these are things like we spoke about the libsum, the config, the so much more. So I was reading this article here, and then I thought here, like for example, here's a like a RCE bypass. Let me just connect. Okay. Bypassing as much as possibly can, I initially built the following payload to remote command execution and will now try and apply as many filter bypass as I can. So let's try this bypass where we can look at the ID, like what IDs, like what output ID can we get from this. So let's test it out with that command. Like for you to understand it, please go and read it more. So let's try that out first. As you can see, we're getting the here's the ID. You see, it does give us. So let's change the ID to like we want to list what is within. Yeah, let's just list what is within this, like what output we get. And if we say list, we will get like we'll see that there's a Docker file, app.py, this flag which we want, these requirements, these stats, this template, all these things. They're so relevant because imagine as an attacker, you want to exploit all this. You want to know what is within the Docker file. You know, I want to understand what is within inside it. I want to know in this app, does it like, is this code controlling? And then I'll find where to modify it. Remember, we're doing injection. So how do I modify? Like, how can I compromise it? And then the flag, which you're going to give the flag, then the requirements to just see what is within the requirements. And as an attacker, what can I do? Let's try out, before we try out the flag, let's just copy this to read out what is within it so that you understand. And then I'm going to change the list to say cat, Control V, and enter. Then let's just come down here. It just tells us it's Flask, which is 3.0.3. Okay, nothing interesting. But if this like was a legit organization, we would literally find so much more. So let's just now find the flag.txt. Sorry. Okay, now here's the flag. We have obtained the flag, so we can just copy the flag and copy, and then let's enter it here. They even give us a hint. Hint says the web application uses Python's Ginger 2 templating engine to load the content of the page. Can you load the content of the page that is stored within the web application directory? Okay, let's copy and let's check. Good, that's correct. And I see that. Let's just scroll down a bit. You see this part. I also saw this part where like if like you need a nudge, here's a solution where it gives us like a solution. We did try out this, we did try out that, and then now here's another one. Request application global built-ins, open flag, read. Let's just see like if we use this command line to yes, let's use that to see what do we get. I know that we already have the flag, but let's just try from the solution that we get. Does it work or what happens? Let's see. So just in case if you're stuck, yes, it does work. The bottom solution, it does work because here's the flag. Here's another way of using the SSTI injection, Ginger 2. Okay, the last true. Okay, finally, let's look at the software or data integrity failure. This vulnerability occurs when application trust codes update or data without verifying their authenticity or integrity. This can lead to attacker introducing malicious changes that the application blindly accepts. We have learned how integrity checks, trust boundary, and secure build pipeline help prevent these issues. So now on our practical, it says this practical would demonstrate a deserialization attack in Python. We can access this practical from this link. Let's just copy the link, and then it says follow the steps in the practical to generate and provide some malicious input to the web. And if you want to explore more about it, here's other two rooms that you can do. So it says here says use Python to pickle a malicious or serialized payload that reads the content of the flag .txt and submit it to the application. What is the content of flag .txt? Okay, let's come back here. Okay, let's go back to our full screen. Open another tab and then Ctrl V and then let's enter. Okay, it takes us here to this page where it says Integrity Lab Insecure Deserialization, and then here's like some content that you need to read. And then deserialize object, enter the base64 encoded pickle data below. The application will deserialize it without any integrity verification. Therefore, if you read anything on this side, it speaks about like we're gonna need to go and create our own Python where we can get the base64. And here at the bottom, I saw that it also grant us the toggle solution. But before we do that, let's just go and create. I already had created it and with the help of the solution. So what we're gonna say is like say nano. Let's name it exploit .py. It's a Python. And Control V. Oh, that's the link to the lab. Okay, let me just go and copy. Okay, I have copied my code that I already had prior created. Here's the code. You can remove the open lines here. They're not necessary, but I'm not going to edit a lot. And then we can say Control X, and then we can say Y, and then we can say Enter. And then let's use Python 3 to run the code. So Python 3 exploit .py. Okay, we see here's the base64 code that was given. So let's just copy it and come here to deserialize it so that we can get our flag. Enter, deserialize. Hopefully it did work, and indeed it did. So we can now just copy the flag. Copy and enter, and voila, it did work. Everything did work. Remember to share your certification. Please do share your certifications on your social media platforms. Don't forget to tag me and yeah, so on. Let's go back again to the room. I did say that I'm going to be showing you the one whereby I used on injection, where I used website for it. Let's go look what did we find from there. So let's just open it and click on it. Website. Okay, here it does accept characters and numbers on our payload. Let's click here again. Are we able to modify it? Let's just change it. Like, let's remove. I'm thinking like, okay, let's just remove. It's going to open another page. Let's just remove the characters, right? Just remove all the characters so that we'll be left with the numbers. And then let's start the attack again. And then we can just close here so that you can try different numbers to see which one works and so on, you know. And from the available one, let's look at what output did it give us. I put it like, I minimized it. Oh, here. It's actually here. This is the one of the characters, and this is how far we got. But you get the gist. I don't want to keep you forever. Do you think we're supposed to highlight the whole thing? Because it's not taking forever, but you will do that. I have just changed the attack from, instead of using characters like your alphabets, because we already have them, I just edited on the 0 so that we can have it as numbers. And then if we just start our attack, I know I keep on just starting it over and over. And from the length, this is like where we'll see which one is different. Like, as you can see, everything starts with 5, 8, 3, 8, the true one, and then this one is 5, 8, 4, 6. They're all quite different. So I don't know. I'm gonna have to sit down and see until it's done. It's gonna perform about how many? 10,000 will take a lot, but do try it out from website, and please do let me know if the attack did work. Did you find the answer from your website? As we already know that we did find the answer from the from the cyber chef, which was very helpful. We did find the answer and we were able to solve together the challenge. Yeah, we were able to get the ticket, the flag actually. Sorry, we just came here and then we tested out because we were already given characters. We just tried out with different numbers and we saw that one was the answer. And we entered it, and then here's the answer. So please do let me know if you try out with Websuit, you find the answer as well, because currently I'm in my phase of learning everything, trying everything with Websuit to see if I can find the answer. Anyway, thank you so much, and I hope this room was really good and you have had a clear understanding of how insecure data handling lead to real-world vulnerability and how attackers actively exploit them. So see you in the next rooms. We are done with all three of the OWASP Top 10 2025. We're going to be exploring more now from all the knowledge that we accumulated.